All right, so we'll begin the exam review. First off, we're going to look at our Chapter 1 section, which was all about limits. All right? When it comes to solving a left-hand or right-hand limit, or the limit as x approaches a specific value, or the defined height of a function, we have to look at the pictures and decide, okay, which curve is which? Well, in this case, the pink curve is f of x, and the blue curve is g at x. So anytime they say f, look at the pink curve. Anytime it says g, look at the blue curve. For the first question, it says f at -2. I want to look at the pink curve. And this actually wants the defined height. So I'm going to go 2 spots to the left. There's an open dot 1 unit high and a closed dot 2 units high. For this particular question, I have to pick the closed dot. Okay? If it's a limit, I can arrive at an open dot or a closed dot. Doesn't matter. It's just wherever you arrive. But when they want f at -2 or g at 1, you have to pick the closed dot. If there is no closed dot, you would say it's undefined. The limit as x approaches 1. So here's what I'm going to do. I'm going to take my straight edge. I'm going to put it at an x value of 1. What does this indicate? I'm approaching from the left side. That's right. So this would be the left side. And I'm looking at the blue curve because it's g at x. All I do is I start out to the far left and I move my way back until I hit the fence or hit the straight edge. What's the height right there? -2. So the answer to this would be -2. And I just so happen to arrive at a closed dot. G at 1. No straight edge required. I'm going 1 unit to the right. I'm looking at the blue curve. There's an open dot at -1 and a closed dot at -2. I want the closed dot. -2 is the answer to that. The limit as x approaches 1 from the right. So I'm going to go back and put my straight edge at an x value of 1, but this time I'm approaching from the right. And if I approach from the right, stop when you hit the straight edge. What's the height right there? -1. Does it matter that it's an open dot? Not if it's a limit. A limit can be an open dot or a closed dot. How do I answer this? It doesn't tell me I'm approaching from the left and right. I check from both sides. I've already done the left-hand limit and the right-hand limit. So what would I say here? The left-hand limit's -2 and the right-hand limit's -1. What does that mean? Doesn't exist. A limit only exists if you arrive at the same height from the left and the right. So look at it. From the left, I arrive at a height of -2. From the right, I arrive at a height of -1. It's not the same answer. It's not the same value, y value. Cool? Therefore, the limit doesn't exist. The limit as x approaches 1 of f of x. I don't have to move my straight edge. I just have to check from the left. On the pink curve, I arrive at a height of 2. And from the right, I arrive at a height of 2 as well. Therefore, the limit exists, and it equals 2. This wants me to move the straight edge 2 units to the left. And I'm going to check from the left and right again. Look at, from the left, I arrive at a height of 1. And from the right, I arrive at a height of 1, even though it's an open dot. So the limit as x approaches -2 of f of x exists, and it equals 1. With me on that? Those are one-sided limits and defined heights and intended heights. Here we have some indeterminate limits. The first thing you should do in all of these examples is try direct substitution. If you put a increasingly bigger x value in and square it, you get bigger values. Multiply it by -3, it becomes smaller. 2 minus a really small number gives you a really small number, or a negative. But when you square it, the numerator is going to infinity, as is the denominator. Infinity over infinity is no good. That is an indeterminate limit. How did we solve limits at infinity? We compare the degree of the numerator with the degree of the denominator. So what I'm going to have to do is I'm going to have to multiply this out. What does it mean to square something? Right. So it helps if you write the numerator like this. What would that give you? 2 times 2. And this would give me -6x squared and another -6x squared. So I'd have -12x squared when I group my like terms. What about this? What's -3 times -3? +9. X squared times x squared is x to the 4th. I'll do the same thing on the bottom. I'll expand it. 2 times 3 is 6. X squared times x squared is x to the 4th. This would give me -10x squared. This would give me plus 3x squared. So I have -7x squared. And this would give me a -5. This is where I divide everything by the highest power present in the denominator, x to the 4th. If I divide every term in the numerator by x to the 4th, 4 divided by x to the 4th would look like this. -12x squared divided by x to the 4th, it would really leave a -12 on top of an x squared. Now what would 9x to the 4th divided by x to the 4th leave? A 9. Wicked. 6x to the 4th divided by x to the 4th would leave a 6. -7x squared divided by x to the 4th would leave -7 over x squared. And -5 divided by x to the 4th would be that, -5 over x to the 4th. Now I can do direct substitution. What happens to all of these terms that have x's in their denominator? They go to 0. Wicked. So I'd have 0 minus 0 plus 9 over 6 minus 0 minus 0. That would end up being 9/6, which would reduce to what? 3 over 2. And that's my answer, 1.5. The further right I move, the closer that function would come to a height of 3/2, or 1.5. What should we try here? So that'd be √2 minus √2, 0 over 2 to the 4th, 16 minus 16, 0. No good. That's an indeterminate limit. So I need to factor, I need to rationalize, I need to expand, or I need to multiply everything by a common denominator. In this case, I'm going to rationalize the numerator, and I'm going to factor the denominator. So to rationalize the numerator, I'm going to multiply by the conjugate. What's the conjugate of √x minus √2? And if I do that to the numerator, I have to do it to the denominator. But I'll also factor this. Okay? What happens when I multiply this out? What's √x times √x? Could it be x? Do you agree that this would be positive √2x and this would be negative √2x? Those would go away. And what's √2 times √2? It's a 2. And it's a negative times a positive, so it's a negative. I have an x minus 2 in the numerator. In the denominator, what type of factoring is this? X to the 4th minus 16. What am I doing there? Difference of squares. And the √x plus √2 just follows. Do I have anything that's going to divide away, or is there a factor yet that cancels from the numerator and denominator? No, but I can go further here. There's another difference of squares. So it's the limit as x approaches 2 of x minus 2 divided by, this would break down into an x minus 2 times an x plus 2. The x squared plus 4 and the square root of x plus the square root of 2 don't go anywhere. But now I can cancel these. It would leave a 1 here and a 1 here. And from there, I can go back to direct substitution. It's not 0 over 0 anymore. The numerator is a 1. What's this going to work out to be? What's 2 plus 2? It is 4. Thanks. What's 2 squared? 4 plus 4. And what's the square root of 2 plus the square root of 2? 1 root 2 plus 1 root 2 would be 2 root 2. This is going to work out to be 1 over 4 eighths are 32 times 2 root 2 is 64 root 2. I would accept that. Some people might rationalize it and call it root 2 over 64 times 2 or root 2 over 128. Now, you don't have to do that because it didn't say to simplify or rationalize your denominator. What did I do from this to this? I multiplied the top and bottom by radical 2. 1 times radical 2 is radical 2. 64 root 2 times 1 root 2 is really 64 times the square root of 4, or 64 times 2, which is 128. Next one, if I fill zeros in, I get 0 because 0 squared is 0. 3 times 0 is 0. This would be 0 plus 2, 4. 0 minus 2, negative 2. Sorry, 0 plus 2 is 2 squared, 4. 0 minus 2, negative 2 squared, 4. 4 minus 4 is 0. So that's no good. That's called an indeterminate limit. Let's factor this one. I could expand it, but then I'm going to have to factor it again probably. What type of factoring can I do in the numerator? X squared plus 3x. It's the first and most basic type of factoring you've learned. Common factor, take out an x. What's x squared divided by x? 3x divided by x. And then I'll do the following. This is something squared minus something squared. So I'll put some square brackets here. To the front of each bracket, I'll take the square root of x plus 2 squared. That gives me x plus 2. To the back of each bracket, I'll take the square root of x minus 2 squared. That gives me x minus 2. I'm going to put this guy in a bracket. And then I'll put the alternate signs between them. And I'll just clean up those bottom brackets. It's going to equal the limit as x approaches 0. I'll still have an x times x plus 3 on top. But you agree that this would be x plus 2 plus x minus 2 if I distribute that positive 1. And x plus x, that gives me a 2x, and 2 minus 2, that's 0. Fair? If I distribute the negative, this would be x plus 2. This would become minus x plus 2. The x's go away this time. What's 2 plus 2? And that gets multiplied by the 2x. I have the limit as x approaches 0 of x times x plus 3 over 8x. And it's the x that cancels. This one cancels this one. I can go back to direct substitution. What's 0 plus 3? And on the bottom, I'm just going to have an 8. There's no x to fill in on the bottom anymore. 3/8 is my limit. I'll leave this one for you. Okay, you could do the same thing, the difference of squares on top. To get rid of an a minus b. But for the sake of saving time, you can try that one on your own. And we'll move to this next question. So flip over into your handout. It says, given the function f of x equals, it's a piecewise function with 4 pieces. Check for any points of discontinuity. Provide a mathematical reason to validate any points where the function is discontinuous. Now, if you were doing this without making a sketch, you would have to check x equals -1. So I find f at -1, it can equal -1 on this piece. I know that f at -1 is going to equal 4. The left-hand limit would be 3 minus -1. I'd use this piece. That would be 4. And the right-hand limit would be this piece right here. These are x values that are on the right. Now I can see right now that it's going to be continuous at 4. Okay? Then I would check and see if it's continuous at 2. Where can it equal to? F at 2 would equal 1. All right? The limit as x approaches 2 from the left of f of x, that would be this piece, these numbers, that's 4. The limit as x approaches 2 from the right of f of x, that would be this bottom piece. 8 minus 2 squared, 8 minus 4, that's 4. So I can see right now that it's discontinuous at x equals 2 because f at 2 doesn't equal the limit as x approaches 2. It would be a point for removable discontinuity. That would be one quick way to do it. But this one wants me to make the sketch. So let's do the sketch first, and you should see that it's continuous at -1 and discontinuous at 2. So how do I do a sketch? I need to make 4 pieces. So let's start with the first piece. I'll say f of x equals 3 minus x. The second piece, f of x equals 4. The third piece, f of x equals 1. And the fourth piece is this parabolic or quadratic section, f of x equals 8 minus x squared. Now remember, when it comes to filling out your charts, your table of values, what x values do I use on the first piece? I use x values that are less than -1. Okay? Now, do I start at -2, -3, -4? I'm going to start at -1 and I'm going to move to the left. Put some dots there to indicate it goes. But if it can't equal -1, why am I putting the -1 in the chart? Why don't I just start at -2? Because it could equal -1.1, or it could equal -1.01, or it could equal -1.5. I can't just start at -2 because I'd be omitting all of the numbers between -2 and -1. So how do I exclude the -1? Open dot, close dot, close dot, close dot. To figure out your heights, you're going to go 3 minus -1, that's 4. 3 minus -2, that's 5. 3 minus -3, that's 6. And 3 minus -4, that's 7. I'm going to go over to my grid and I'll plot these points. 1 left, up 1, 2, 3, 4. Open dot. 2 left, up 5. 3 left, up 6. 4 left, up 7. And I will join them with a nice straight line, and I'll put an arrow pointing to the left. You with me on that? What x values go in this next chart? It says x is greater than or equal to -1, but less than 2. So I'm going from -1 all the way up to +2. Close dot here because it can equal -1. Close dot here, close dot here, open dot there because it's just less than 2. Nope. -1 all the way up to +2. So that means x is greater than or equal to -1, but less than 2. So it's -1 to 2, -1, 0, 1, and 2. How do I exclude the 2? By putting an open dot. Why do I exclude the 2? Because it's less than 2. Why don't I just cross it out altogether? Because it could be 1.9 or it could be 1.99. I can't just stop at 1. What's the y value for all of these? What would f at -1 equal? 4. What would f at 0 equal? Also 4. F at 1 is 4, and f at 2 is 4. You have a horizontal section here. So I'm going -1 comma 4. I've been there already. I'm going to fill it in. Remember, if you have closed dots and open dots on the same spot, who's the boss? Closed dot always wins. A closed dot fills in an open dot. An open dot on top of a closed dot doesn't open it up. It remains closed. 0, 4, 1, 4, and 2, 4. And I join those with a straight line or a line segment. There's no arrow on either end. It doesn't go to the left of -1 or to the right of 2. Not that particular section. What's going on here? The third piece, it says f of x equals 1, and it says when x equals 2. I'm literally putting 1 dot, 1 x value. What does f at 2 equal? 1. This is how you get the little suspended dot kind of floating or hanging there. I don't connect it to this one. And then the last piece says for x values greater than 2. So that means 2, 3, 4, 5, dot, dot, dot. It's going to go right forever. How do I exclude the 2 if it's just greater than 2? Open dot. This would be closed, this would be closed, this would be closed. Why don't I just remove the 2 and start at 3? Could be 2.5, could be 2.1 or 2.01. What's f at 2 going to equal? 8 minus 2 squared, that's 8 minus 4. 4. What's 8 minus 3 squared or 8 minus 9? 8 minus 4 squared, 8 minus 16 is -8, -8. And 8 minus 25, -17. I won't even bother plotting that point. 2, 4, open dot on top of an open dot remains open. 3, -1. And 4, -8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to try and make this into like a curved parabolic shape. All right, took a bit of a weak spell there, but that's the best I could do. Good? Now, when it comes to continuity, remember, a function's continuous if you do not have to lift your pencil to draw the curve. It's discontinuous anywhere you have to lift your pencil. Okay, where is it discontinuous? Continuous at x equals what? It's discontinuous right here. What's that x value? 2. The reason, okay, f at 2 equals 1. It does have a defined height. The limit as x approaches 2 of f of x. Check from the left. If I approach 2 from the left, I arrive at a height of 4. If I approach 2 from the right, I arrive at a height of 4. So that equals 4. That's the reason it's discontinuous. Because f at 2 does not equal the limit as x approaches 2 of f of x. 1 doesn't equal 4. Anyone remember what type of discontinuity that is? We have a removable discontinuity. Or a point discontinuity. And we have one more question. We'll talk about the limit definition of the derivative. So we used a limit to solve for a derivative. And you would get this equation on the exam. Everyone okay with that? And just to prove a point, we said it was discontinuous at x equals 2 up here as well in the opening. Flip over, you got this? So step 1 is to find f at x plus h. That means take your f at x equation and replace all of the x's with x plus h. When I solve this, remember to square something means to multiply it by itself. There's my x squared. That's an xh. That's another xh. You could call it hx if you want. And there's an h squared. When I group my like terms, 1xh plus 1xh is 2xh. So I have 5 times those 3 terms, x squared plus 2xh plus h squared. Minus 7 times x plus h plus 1. Squeeze it in there. In the next line, I'll distribute the 5. What's 5 times x squared? What's 5 times 2x? And what's 5 times h squared? I'll distribute the negative 7. It's negative 7 times x, negative 7x, and negative 7 times h, negative 7h. Those both should change signs. It's a negative 7x minus 7h, and then I have a plus 1. That's what f at x plus h is. To figure out the derivative, f prime x, that's the notation for the derivative. We're going to use the limit as h approaches 0. This comes from the tangent problem. F at x plus h. That's these 6 terms right here. 5x squared plus 10xh plus 5h squared minus 7x minus 7h plus 1. And then I'm going to subtract these guys right here. Are you okay with me distributing this negative sign over those 3 terms right now? This would become a minus 5x squared. This would become a plus 7x. And this would become a minus 1. What's it all over? H. Group your like terms. (5x squared minus 5x squared), they're gone. I have 10xh plus 5h squared. The negative 7x plus 7x, they're gone. The negative 7h can't go. The plus 1 minus 1, they're gone. Now I have an indeterminate or a limit. Try and solve the limit using direct substitution. What's 10x times 0? 5 times 0 squared. Minus 7 times 0. Over, no good. It's an indeterminate limit. How do we solve an indeterminate limit on the second page of our review? I'm going to factor. What can I take out of the top? I can take out an h. That would leave 10x plus 5h minus 7 over h. These h's will cancel. Once you expose the factor that is common to both the numerator and denominator and divide it away, now direct substitution will work. It's not going to be 0 over 0. The bottom is going to be a 1. Anywhere there's an h remaining, fill in a 0. So I can say that f prime x will equal 10x plus 5 times 0 minus 7, or 10x minus 7. And real quick, if you remember the power rule, what was f of x equal to? 5x squared minus 7x plus 1. Yeah. Think of your power rule. 2 times 5 is 10, x to the first. 1 times negative 7 is negative 7, x to the 0. X to the 0 is just a 1. What's the derivative of a constant? 0. So the power rule to check it. That's what we'll focus on tomorrow. Power rule, product rule, quotient rule, chain rule, combining rules, and then some applications of derivatives. Cool? You guys can go to work on your sheet.